Hi, everybody. Professor Leach. Today, we want to look at the unit circle again. So I've drawn a unit circle, and we need to learn, and I've drawn a 30, 45, and 60-degree reference angle in each of the four quadrants. And I labeled those on the inside. So here's our 30, 45, and 60 in the first quadrant. And in the first quadrant, the reference angle is just the angle itself. And what we want to do is recognize all these angles going around the unit circle so that certain certain angles will be known exact values of trig functions. That's really what we're going for. We really want to say apply sine and cosine and tangent of 30, 45, and 60 all the way around the unit circle. So for each of these, we want to be able to say what's the sine of 30, the sine of 45, and the sine of 60. So sine of 30, we know is a 1/2. Sine of 45 is √2/2. And sine of 60 is √3/2. In the first quadrant, sine, cosine, and tangent are all positive. So it's all plus positive for sine of 30, 45, and 60. We also want to know cosine of 30, 45, and 60. These are just values that we want to remember. We don't have to sit down and memorize them, but we do have to remember them in some fashion. So I want to apply cosine all the way across for 30, 45, and 60. I've started this multicolor thing, and so now I cannot stop. So it's going to take me a long time to do this. So cosine of 30, if we remember that the sine and cosine of complementary angles will be the same. So cosine of 30 is the same as the sine of 60, so √3/2. We're just looking for all the patterns that will help us remember these values. And they're all positive because in the first quadrant, all are positive. In the first quadrant, all are positive. So let's just continue going around the circle and identify sine and cosine of 30, 45, and 60. I left off tangent because I ran out of space. So sine and cosine of 30, 45, and 60, and identify what angles we have in each of these quadrants. So a 60-degree reference angle in the second quadrant. What angle is this if we measure from X? What's the theta equal to for 60 degrees? And I'm going to write the value of the angle on the outside. So 30, 45, and 60. Then we get up to 90 up here, starting off at 0 down here. So a 60-degree reference angle corresponds to a 120-degree angle. So 60 degrees in quadrant 2 is 120 degrees. 45 degrees in quadrant 2, well, it's just going to be 15 degrees later, so it's 135. And 30-degree reference angle in quadrant 2 is 150 degrees. So these are three more angles that we need to recognize: 120, 135, and 150. We want to recognize those angles, and we want to identify their associated reference angle. 120 has a reference angle of 60, 135 has a reference angle of 45, 150 has a reference angle of 30. Then we want to use that information to find the sine, cosine, and tangent of 120, 135, and 150. So the sine of, I'm going to go this order, 30, 45, 60. So the sine of 150 degrees. Now we need to combine this with the quadrant information. And we know that in quadrant 2, sine is positive. And that means cosine and tangent are negative. So the sine of 150 is the same as the sine of 30, a positive 1/2. The sine of 135, we get the value from the reference angle. And the sine from the quadrant. The value from the reference angle and the sine from the quadrant, sine positive or negative. And then sine of 120 be √3/2. If ever we're unsure, we just say, hey, let me make sure I'm sure. So sine of 135, √2/2, because we identify 0.7071 as a square root of 2/2. Sine of 120, √3/2, because we're making these associations. When I switch over to the cosine, if I want the cosine of 150, I'm going to run into space issues. So when I calculate the cosine of 150, I get the value from the reference angle. Cosine of 150 will have the same value as the cosine of 30, √3/2. But in the second quadrant, cosine is negative. In the second quadrant, cosine is negative. And so all of my cosine values in the second quadrant will be negative. So if I want the cosine of 135, the value comes from the cosine of the reference angle, 45, √2/2. And the sine comes from the quadrant. In the second quadrant, cosine is negative. And then finally, because I can't leave one blank, like physically pains me to leave things blank like this, cosine of 120, which has a 60-degree reference angle, gets the value from the cosine of 60, which is 1/2, and the sine from the quadrant. And in the second quadrant, cosine is negative. What we want to do is we want to build this out all the way around so that we have random recall for any of these values, so that I can randomly pick what's the cosine of 60, 1/2. What's the cosine of 210? We want random access to all these different values. This is like your this is for trigonometry, this is your times table. You got to have random access to your times table. 7 times 8 is 50 something or whatever it is. You want random access to any point on that table. I think it's really helpful to just draw yourself a circle with the angles going around 30, 45, and 60. Figure out what the what angles those reference angles correspond to, and then write sine, cosine, and tangent for all 3 of those reference angles. Question?
Yeah. So how come when like the sine of 150 degrees in the top left there,
Yeah.
you have 1/2 that comes from the sine of the reference angle?
Yes.
And so when we're doing that, we're not supposed to be using like a reference reference trig function. It's always going to be the same. I mean, trig value or
Yes. So the idea is that when we look at we're trying to expand trig functions and apply them to angles beyond the right
yeah.
triangle. In a right triangle, if we have a 30-degree angle, the sine of that 30-degree angle is 1/2. That'll be the ratio of the side opposite to the hypotenuse. The right triangle in 150-degree angle, we're going to build a right triangle down to the x-axis, and it will have a 30-degree reference angle.
Yeah. Okay.
So it'll still be opposite over hypotenuse for the 150. So the value, the 1/2 part, that comes from sine of 30, comes from the reference. But in the second quadrant, we haven't got into all the all the details about the unit circle, but in the second quadrant, sine is positive, cosine and tangent are negative. I haven't justified that in any way at this point.
Oh,
like,
okay. Yeah, I
know
remember
that-
you like briefly went over that in quadrant 2 with what's positive and negative.
Right.
But okay, so you are going to like break that down more because
Yes.
that was my other question. It's like
Why is sine positive in quadrant 2
Yeah.
and why are cosine and tangent negative in quadrant 2? Yes, but we need to get our times table built first. Once we build the times table, then we can go back and notice some more things. So we just gotta hang with it
Sounds legit.
till we get there. So we do the same thing going around into quadrant 3. And then we do the same thing going around into quadrant 4. We first want to figure out what angles we're going to be looking at that are in quadrant 4. So 0 degree reference angle is also 360. And this is why we only need to worry about between 0 and 360, because we could always do anything past 360 is in the same location as something that's between 0 and 360. But we want to figure out what angles in the fourth quadrant we're going to have. So a 30 degree reference angle is, let's see, 30 degrees before 360 is 330. A 45 degree reference angle in the fourth quadrant is a 315 degree angle. So these are ones that should be noticeable to us. We should notice what's going on here. 300 should also stand out because a 300 degree angle is a 60 degree reference angle in quadrant 4. And then we have to remember that in quadrant 4, cosine is positive. And that means that sine and tangent are negative. So we're making lots of associations. We're trying to build a lot of pattern into this so that we can remember these. We want random access to these things because I want to be able to say, what's the sine of 315 degrees? And you need to pop out negative square root of 2 over 2. There's a lot that goes on in making that decision really fast. When I said sine of 315, you envision the 315 in the fourth quadrant with its 45 degree reference angle. I said sine of 315. So the 45 degree reference angle tells you the number that you're going to use is root 2 over 2. And since it's in the fourth quadrant, sine is negative in the fourth quadrant. So we want to be able to find these values quickly. We want to be able to use our calculator to figure out the sine of 315 because we're not going to be sure here at the beginning. And it's negative because it's in the fourth quadrant and it's negative square root of 2 over 2. Calculator is going to give us decimal values, so we want to recognize those as well. Geez, I'm asking you to remember a lot. Seems kind of crazy. But it only seems like it's a lot to remember because it's a lot to remember. So don't worry about it. I don't know if that's very comforting. We want, say, sine of 330, and we just want to do this exercise all the way around the circle. And then we want to calculate the sine of 315. And then we want to calculate the sine of 300 because I care about a 30, a 45, and 60 degree reference angles in each of the 4 quadrants. The values come from the reference angle. So sine of 330 with its 30 degree reference angle will be a 1/2. The sign, positive or negative, comes from the quadrant, negative 1/2. Sine of 315 is, I'm gonna have to go sideways because I didn't write myself enough space. Root 2 over 2 because of the 45 degree reference angle, negative because of the quadrant. Sine of 300 is going to be square root of 3 over 2 because of the 60 degree reference angle, and negative because it's in the fourth quadrant. Any questions? So musicians, this is this unit circle, going around the unit circle, this is your circle of fifths.
Yeah, I made that connection immediately, and it's freaking me out.
Yeah, it's just another circle to put together. Don't start mixing them. So don't be like in band practice and be like, oh, wait a second, what's the reference angle for A minor? And they'll be like, oh, wait, what? So, well, A minor is in the first quadrant, so it's positive, right? But A minor is sad, which is kind of a negative thing. So now I'm all confused. You know what I mean? Is A minor in the first quadrant? I don't know. Cosine of 330 with its 30-degree reference angle, we get the value from cosine of 30, so it's root 3 over 2, and it's positive because we're in the fourth quadrant, and cosine is positive in the fourth quadrant. Cosine of 315 is root 2 over 2. Cosine of 300 will be a half because of the 60-degree reference angle. It only seems like it's a lot to remember because it's a lot to remember. But I assure you, you'll have no problem remembering it. What you have to do is interact with the unit circle a lot, and then you'll just start remembering it. You don't have to sit down and actively try to memorize things by like sitting there quizzing yourself. It's like, okay, this. Sine of 30 is a half, sine of 45 is root 2 over 2. However you memorize things. If you just draw this a couple of times and include the tangent information that I left off because of space, and include your tangent information, you'll have it down very quickly. A lot of times we will struggle with remembering this kind of information kind of because we don't want to remember it. You're like, well, I don't want to waste hard drive space on this information. I would like to know the lyrics to the, I don't know, whatever, the current top 10 on Spotify. I would rather know that because it's more applicable, because it's more fun. You know what I mean? I assure you, there is plenty of space for you to remember this. Any questions? Comments? Snide remarks? As evidence for plenty of room to remember, plenty of room to remember very weird stuff. Is anybody familiar with the show Animaniacs? It was in the 90s, and it is one of the greatest shows of all time. Fight me. It's a wonderful show. Look it up on YouTube or wherever they play it on some streaming service, if it's on some streaming service somewhere. But one of the songs was called Yakko's World, and it was just singing a list of the countries of the world at the time. They left off a couple of them, but it's just a list: United States, Canada, Mexico, Panama, Haiti, Jamaica, Peru, Republic Caribbean, Republic Dominican, Cuba, Caribbean, Greenland, El Salvador, too, Puerto Rico, Colombia, Venezuela, Honduras, Guyana, and still Guatemala, Bolivia, then Argentina, and Ecuador, Chile, Brazil. So I want to bet because I learned that because I was driving to Hayward every day. So I had a nice long commute. And that was in the mid 90s. And I still remember it all the way through. A weird flex, but okay, right? But there's plenty of room to remember all this ridiculous stuff. So don't worry about, don't look at it and say, this is too much to remember. Because I remember this, and I'm old, and my brain is breaking down. So there you go. If I can still remember this, y'all will have no problem with your young brains that work. All right. Did the Animaniacs do a quadratic song? Oh, now I have to find out. So the quadratic song I know is just to Pop Goes the Weasel. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's a good way to remember the quadratic formula. But the more important thing to remember about the quadratic formula is that the quadratic formula is trash and we shouldn't use it to be solving quadratic equations. There are better things to do that will demonstrate we actually understand what's going on. So all of you, that's throwing down the gauntlet to all of you proponents of the quadratic formula. I'll say it again, the quadratic formula is trash and we can do better as a species. All right. So that's what we want to do. I want you to learn sine, cosine, and tangent of 30, 45, and 60 all the way around the unit circle. I want you to learn your quadrants. All are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. Sorry, here. In quadrant 3, tangent is positive. And that means that sine and cosine are negative. And in quadrant 4, cosine is positive. So sine and tangent are negative. Here's how you will remember those. and this is a good way to remember those. Cosine is positive wherever x is positive. Sine is positive wherever y is positive. So cosine is positive when x is positive. So that's quadrants 1 and 4. Cosine is positive when x is positive. Sine is positive when y is positive. 1 and 2. Cosine is positive when x is positive. Sine is positive when y is positive. That leaves out tangent. Tangent is positive when sine and cosine match, because tangent is sine over cosine. Tangent is positive when sine and cosine are the same sign. Tangent is positive when x and y have the same sign. That puts us in quadrants 1 and 3. In quadrant 1, x and y are both positive. In quadrant 3, x and y are both negative. And since tangent is sine divided by cosine, the negatives cancel and become positive. So tangent is sine over cosine. So positive over positive is positive, negative over negative is positive. So tangent is positive when x and y agree. That's in quadrant 1 and quadrant 3. That rhymed, but it doesn't have any rhythm, so we won't remember it that way. Any questions? This is what the next quiz was supposed to be, but it didn't publish when I thought it was going to publish, so I have to publish it today. So this is what it's like being in my class. If you had a professional teacher that knew what they were doing, like all the quizzes would be up there and the class would all make sense. But you got me, and I just disappear for a long weekend. So I don't know. That's just the risk that you take when you sign up for Leach's class. Write bad things about me on ratemyprofessor.com, and it'll be funny. If you've never heard of ratemyprofessor.com, don't worry about it. It's like Yelp for teachers, and it's a bad idea. What is a good idea, though, is, I don't know if the site still exists, a site called Professors Strike Back, and this is video responses to professors reading their own reviews. And it is funny because some of them take it very seriously. So if you want to say bad things about me on Rate My Professor, I know what all my flaws are as a professor. I've been doing this for over 20 years. And I kind of know what the problems are. And some of them, I know what I can do to fix them. And some of them, I'm just not sure I can. I think I've been doing this too long. I think those things become a big problem. They go, okay, Leach, we're gonna come on out. See, we're gonna take you up to a farm upstate, and you're gonna have lots of space to run around on. I don't want to run around. I'm old and broken. You know what I mean? So, this is not an accurate comparison, but like, you got to take the good with the bad. Like no one cares that Shaquille O'Neal can't shoot free throws. I'm not saying that I'm like the Shaquille O'Neal of math, of teaching math, but no one cares that Shaq can't do free throws because he's so good at every other aspect of the game. We'll let that one slide. You know what I mean? It's like if your pitcher can't hit, no one cares. If he's a good pitcher, we'll let the hitting thing slide. There's 8 other dudes that we can rely on for the hitting part. So I know what my flaws are. Feel free to go ahead and point those out on Rate My Professors. Every time I look at that, I don't look at that very often because it is a good way to find out who I flunked. But I know what those flaws are. Go ahead and point them out. And whenever I see those flaws, I'm like, oh, yep, that is something I'm aware of. And it's something I've been working on for 20 years, and I don't know if it's going to get fixed. You know what I mean? Anyway, your job is to learn this unit circle all the way around. Because what we're going to start doing, and learn your positives and negatives in this way. Cosine is positive when x is positive. Sine is positive when y is positive. Tangent is positive when x and y match. Because what we're going to do is we're going to assign to a point, to an angle theta. On the unit circle, the coordinates here are going to be cosine x, or cosine theta, sine theta. So the coordinates going around the unit circle, the x coordinate is the cosine. So cosine is positive when x is positive. And the y coordinate will be the sine. So sine is positive when y is positive. This will allow us to calculate the cosine and sine of any angle, not even just between 0 and 360, not just limited to your right triangles, not just limited to once around the circle, but anywhere on the circle. This will allow us to build functions that have really cool graphs for things that go up and down. I can't draw them very well. I don't understand why drawing something more often makes it look worse, but also better. Sketching is so weird. All right, that's going to do it for today. I want you to learn your unit circle. You've got until Monday to have all these values down. I'll put up a quiz that'll just be like, know your values. And it'll be values of your reference angles, your trig function values, and your signs, positive and negative. Any questions before we go? That's it for today. Y'all have a nice weekend. I'll see you on Monday, and peace.
Thank you.
Out.